Let's change out some lengths in the metric system by paying attention to what prefix that we're in and then what one we want to go to. So in our first example, we're going to change 3.6 kilometers to the base unit of meters. Because the metric system is based upon powers of 10, to convert from one unit to another unit in the metric system involves pretty much just moving the decimal point. But we need to pay attention to whether or not we want to move the decimal point left or right, and then how many spots we want to go. So this table right here is a nice way to visualize which way you want to go and then how many spots you want to move. Right now I am in kilometers, okay, which should be right here. We want to ultimately go to meters, or our base unit, which is right here. To get from kilometers to meters, it's a movement of 3 spots, and since the unit I'm trying to go to, meters, is a smaller unit than the kilometers, I will end up with more meters for my final answer. So because I want to end up with a larger quantity of meters, from here to here we're going to move the decimal point right 1, 2, 3 spots. So in this number right here, the decimal point is right here. I'm going to move it 1, 2, 3 spots to the right. In order to do that, I'm going to need to put in some filler zeros. So to change 3.6 kilometers to meters, this would be 3,600 meters. Okay, so we needed to know which way to move the decimal point. So from the kilo prefix to our base, we are going to go right. Okay. And then looking at the powers of 10 I need to adjust, we're going to need to go right 3 spots. If we want to set up a more formal conversion factor, how we would do that is we would put the given information, which is 3.6 kilometers. We put it over 1, just to be very clear, this is in the numerator of a fraction. And we could set up a conversion factor with the units I'm trying to cancel being on the diagonal of where they currently are. So in my new fraction that I'm going to build right here, kilometers is going to go in the denominator. Now I'm going to look for the relationship between kilometers, which is the units I'm in, and meters, which is the units I want to go to. And then this table tells me the relationship that, looking at here when we talk about the powers of 10, a kilometer has 10 to the third meters in it. So 1 kilometer has 10 to the third meters in it. And if you wanted to, you could use 1,000. I tend to use the powers of 10. Because this up here in the numerator then tells me, basically it tells me this information right here. Multiplying by tens or multiples of tens are all about moving the decimal point. So again, my kilometers units are going to cancel because they're on the diagonal. And then looking at then my units for my final answer are going to be in meters. And then this tells me then whether or not I want to multiply or divide, or conversely if I want to move the decimal point right or left. So since I'm going to be multiplying by 10 to the third power or 1,000, we want to take this decimal point and move it right 3 spots. And so when we move it right 3 spots, we get the same final answer. Okay, so that's just a little bit more of a formal way to do the conversion. Let's take a look at the next example. We're going to change 4 meters to centimeters. So again, using this table up here, I'm in meters and I want to go to centimeters. All right, so we are in our base unit of meters, and I want to go to centimeters. From my base to centimeters, I would be moving right 2 spots to get to the prefix I want to be in. So I'm going to take this number right here. This is where we're pretending the decimal point to be. It's right after the 4. Then we're going to move it right 2 spots. I'm going to need to put in some filler zeros. Okay, so this ends up being then 400 centimeters is equivalent to 4 meters. All right, so instead of just doing the decimal point moved, if you wanted to set up a more formal conversion factor, again, I'm going to put my 4 meters over 1. I'm going to multiply this by a fraction where I'm going to convert the units from meters, which is what I'm in, to centimeters, which is what I want to go to. And then this table right here tells me, all right, so looking at this, we can write up the conversion factor a couple different ways. This exponent right here relates to how this prefix connects to the meters. Okay, so I have 10 to the negative 2 power meters is equivalent to 1 centimeter. Now working with this negative exponent is hard. So again, this is relating the centimeter to the meter, where we could write this 10 to the negative 2 as its decimal equivalent, which would be 0.01 or 1/100th. Okay, so 1 centimeter is 1/100th of a meter. And we could do the calculations that way of 4 and then divided by 0.01. But again, I like to work with powers of 10. I find that to be a little bit easier because the powers of 10 let me see if I move the decimal left or right. And again, negative exponents tend to be a little bit goofy. So an equivalent way of setting up this problem, again, I'm going to take my 4 meters and I'm going to put it over 1. But I like to think about this, and suppose to that 1 centimeter is 1/100th of a meter. I like to think about that I would have 100 centimeters in 1 meter. Okay, so as opposed to having 10 to the negative 2 next to meters, I'm going to write this as 10 squared or 100, and I'm going to put that next to that smaller unit, next to that centimeters. So that's how I like to set up these ones if I'm going to do the these conversion factors. Because this then tells me, again, my meters cancel because it's on the diagonal, and this then tells me I'm going to move the decimal point right 2 spots. Okay. So again, I get my same answer of my 400, and my units for my final answer are centimeters. Alright, so here's just a couple different ways of thinking about converting from meters to centimeters, depending on kind of how you want to think about it. So what if I want to convert and one of the units is not my base? How do I end up doing that? So we're going to change 230 millimeters to decimeters. Alright, so again, if we go back up here to this table, and right now I am in millimeters, which is right here, and I want to go to decimeters, which is right here. So notice, to get from milli to deci, we're going to go left 2 spots. All right, so for this conversion right down here, then we want to go left 2 spots. So in 230, the decimal point is right here. So if I go 1, 2, the decimal point ends up being right there. So this would be 2.3 decimeters. Or you could write it as 2.30. And this one, if you wanted to, you could keep that 0. Which will talk about the degree of accuracy that this measurement was done to. Alright, so that's using the table. Now if we wanted to set up conversion factors, the 230 millimeters would go over 1. And again, the units I'm trying to cancel would go on the diagonal, which would be down here. And then how I can use this table is, again, keeping in mind these powers of 10, this row right here talks about how the prefixes relate to the base. Okay, so but if I want to talk about how one prefix relates to another prefix, we can look at the adjustment in what happened with the exponents. All right, so looking at milli versus deci, right, because these guys' exponents are off by 2, and milli is the smaller of the units, what this is going to tell us, okay, is that there are going to be 10 squared or 100 millimeters in 1 decimeter. And again, how I know that is looking at these exponents. These exponents are off by 2. Okay, and I don't like the negative exponents, again, get a little bit goofy. So as opposed to analyzing with the negative exponent, I just think about when I look at the smaller of the units. Okay, so then there's going to be 10 squared or 100 millimeters in 1 decimeter. So I'm going to use that as my conversion factor. There's 10 squared millimeters in 1 decimeter. So again, my millimeters units are on the diagonal and they cancel. And on this one, because this guy is in the denominator, okay, I'm going to be dividing by 100. And when you divide by a power of 10, you're going to move the decimal point left, however many zeros there are. So we're going to move left 2. Notice right here, when this 10 squared was in the numerator, we're going to be multiplying by a power of 10. Okay, so this was on that previous example about the 4 meters to centimeters. On our conversion factors, we multiplied by 100. So when you multiply by a power of 100, you're going to move the decimal point right, however many zeros there are, or however big that exponent is. Okay, so this then tells me that I want to move the decimal point left 2 spots. So again, for my final answer, I end up at 2.3 in decimeters. Let's see that one more time. Last conversion, let's change 2.8 centimeters. Actually, I don't think this is the last one. I think, yep, we got one more. All right, so here we go. 2.8 centimeters to decameters. So I'm in centimeters. I want to go to decameters. Coming back up here to this table. I am in centimeters, which is right here. I want to go to decameters, which is right here. All right, so to get from centi to deca, it's 1, 2, 3 jumps to the left. All right, so let's come back down here. All right, so in 2.78, we want to go left 3 spots. Okay, so I'm going to put my pencil where the decimal point is and go 1, 2, 3. That's where I want my decimal point to be. We're going to need to put in some filler zeros on that one. So then my final answer would be 0.00278 and then decameters. Solving the same problem using conversion factors, I'm going to put 2.78 centimeters over 1. I'm going to set up a new fraction with centimeters in the denominator. And then coming back up to my table then, the relationship then from the centimeters to the decameters, okay, looking at what's happening with the exponents or for how many jumps that I have. Okay, so this is 1, 2, 3 adjustment in the exponents. Okay, so this means that I have 10 cubed or 1,000 centimeters in 1 decameter. All right, and then again, because I'm going to be dividing by 10 cubed or 1,000, we want to move the decimal point left 3 spots. Okay, so when you multiply by a power of 10, you move the decimal point right. When you divide by a power of 10, you move the decimal point left. That only works when your exponents are these whole numbers. If your exponents are negative, the rules obviously get reversed or backwards. That's why I like to set these guys up using negative exponents when I write my conversion factors. All right, so my centimeters units cancel on the diagonal. I'm going to move my decimal point left 3 spots, and we still get the same answer we got before, just using our table. All right, so here's one last one. I encourage you to try this one on your own, just to see if you're getting the hang of this. And then after you have a chance to try working through it, then compare it to what I'm about to do. All right, so here we go. We want to change 60 hectometers to kilometers. So I'm going to come back up here to my table. All right, I'm in my prefix for hecto. I want to go to kilo. That's only 1 to the left. Okay, so this means then when I want to do the adjustment, I want to go left 1 spot. Okay, so in the number for 60, if the decimal point is here, if I move it left 1 spot, I would end up with the decimal point after the 6. So you can write it as 6.0 kilometers, or you could just write it as 6 kilometers. If you wanted to set up using conversion factors, the 60 hectometers would be put over 1. And then the conversion factor, going back up to the table, because these guys are off by a step of 1, that is 10 to the first power, or just 10. There's 10 hectometers in 1 kilometer. All right, so the units on the diagonal cancel. The units I'll be left with are in kilometers. And then this, because I'm dividing by 10, I want to move the decimal point left 1, so then I still get my same answer of 6 kilometers. Okay, so again, when we do the conversions in the metric system, in this one we've just been exploring a bunch of examples converting out different lengths. Since the metric system is based upon powers of 10, you end up just moving the decimal point either left or right to convert from one unit to the other unit, but you have to know whether or not you're moving left, moving right, and then how many spots you want to move that decimal point.